Thank you, everyone. Good morning. Right before we started this session, the panel and I were discussing home brewing, so we actually may have an impromptu home brewing session later that people may want to attend. My name's Keith Stouffer. Just a real quick background on myself. I've been at NIST now for 27 years. Started working doing robotics work, machine tool control work back in the late 80s, early 90s. In the late 90s, we started doing some work in doing remote access for collaboration to these types of systems, and it kind of clicked as like, we're doing this, it's really cool, but no one is really thinking about security at all. So we started our security work for industrial control systems. It was right around 2000 or so. So we've been doing this for about 17, going on 18 years. Like I said, I work for NIST. NIST is under the Department of Commerce. We are a non-regulatory agency. We're a relatively small agency. We only have about 3,000 employees. We have just about as many guest researchers. We have two main campuses. The main campus is in Gaithersburg, Maryland, where yesterday it was rainy and 40, so it's much nicer here. And we also have a facility out in Boulder, Colorado. The main research areas that NIST is concentrating on right now are advanced manufacturing and IT and cybersecurity. So this area really hits home for NIST in its research. Like I mentioned, so NIST has been collaborating with industry, government, academia for about 16, 17 years or so to develop standards and guidelines and then methods and metrics and tools to enable manufacturers to implement a cybersecurity program within their systems while also addressing the things that make industrial control systems different. So they're demanding performance, reliability, and safety requirements. Some of the documents and products I'm going to talk about during this talk are a NIST special publication, 882, which is a guide to industrial control system security, the ISA-IEC suite of standards, and then a new document that's been produced, an implementation of the cybersecurity framework for manufacturing systems, so a cybersecurity framework manufacturing profile. So why are we doing this? And you saw this earlier today in, I think, both Doug and Clint's presentations. So in 2016, of the 290 incidents reported to the NCCE, 63 of those, so the highest out of the 16 critical infrastructures, were in the critical manufacturing sector. So it is being targeted. And the number one threat vector is still spear phishing. I mean, you heard earlier, I think Doug was saying, we're all humans. And unfortunately, humans still make mistakes. And that really, the vector that most people are getting in and causing incidents is really through spear phishing. So 882. This is a document that's been around for quite some time now. We had the initial draft out in September 26. And like I said, what this document does is provides guidance on how to develop and deploy a industrial control system cybersecurity program. Everything from training aspects to how you do network segmentation and segregation to how you do various different technology implementations within the system. It's one of the more downloaded and used documents for industrial control system security. Mostly, I think because, as Clint said, it's one of those documents that's already been paid for. It's not free, but it's already been paid for, so it is available to everyone for free. Whoops. Another very good resource for everyone who's doing industrial control system or industrial automation cybersecurity are the ISA-IEC 62443 suite of standards. They're a very good resource that provides everything from how to develop and deploy a cybersecurity program to listing out technologies that are available to how you segment your network. So it's another very good resource for developing and deploying a cybersecurity program specific to your types of systems. It's going through fast. The other document that I want to talk about is the Cybersecurity Framework Implementation of the Manufacturing Profile. Are most people aware of the Cybersecurity Framework? Yes? No? Some of you? So the Cybersecurity Framework was developed probably three or so years ago. What the intent of the Cybersecurity Framework was to develop an overall cybersecurity framework for all of the 16 critical infrastructures. So it's a fairly high-level type of requirements document since it has to go across the board. Now, if you want to have a document that's specific to a particular sector or industry, you develop what's called a profile of that document. So what we've done is we've taken these high-level requirements that are in the cybersecurity framework and then added in the necessary information to make it implementable in a manufacturing environment. And that's what's called a target profile. So again, this is just an overview of what the cybersecurity framework is. Up in the upper right-hand corner there, you see what it's called the framework core. Those are those overall high-level requirements. And then the profile is the implementation of those requirements in a particular sector. So we published the Cybersecurity Framework Manufacturing Profile in September of last year. So again, this is an already paid for document that's free for everyone to use. And like I said, so what it does is, so this is a specific implementation of the cybersecurity framework for manufacturing systems. Now, what we're doing is, since I go out and talk to quite a few people, I always hear, there's a lot of good guidance out there, a lot of good standards out there for everyone. But what would really be helpful, at least to a lot of the people that I talk to, is some implementation guidance on how to implement these types of standards and guidelines. So what we're doing is we're taking the cybersecurity framework manufacturing profile and implementing it in a test bed that we have at NIST. So what we're doing is we're taking the medicine, seeing how bad it tastes. Is it hard to implement? Is it easy to implement? What are the best ways to implement it? We're seeing what the side effects are of the medicine. Does it cause performance impacts that then create operational impacts to the system? And then also seeing how well the requirements then protect the system from cybersecurity threats. So again, the test bed, we're doing implementation of the cybersecurity framework. We're looking at things as to technical areas such as how we do perimeter network security, host-based security, INA, encryption, some higher-end technologies such as anomaly detection, how you do zone-based security, what to do about field bus protocols. Do we need to be concerned about the security of those non-routable protocols? And are there ways to develop more robust fault-tolerant systems? So testbed scenarios. So we have several different scenarios that we have in the testbed that we have in NIST that we're doing this implementation on. One is a continuous process. We have a chemical process that's running there. We have a couple discrete processes where we have a collaborative robotics setup. and then also some additive manufacturing. We also have some distributed operations for the more SCADA type of systems. We're doing some smart transportation work, and then also we're connecting up with the smart grid work that's happening at NIST as well. So the process control scenario. So the process control scenario, we have a complete hardware and software control system. Since the test bed is relatively small and NIST frowns upon putting process control plants on site, the actual process itself is simulated or emulated, but as far as the PLC and the software is concerned, it's actually controlling a real plant. So it's called hardware in the loop. Our Colaborative Robotics is full hardware top to bottom. We have some small KUKA robots that we have using EtherCAT protocol. We also have some computer vision systems embedded in there. We also have a safety system integrated in with the process or with the control system, so we can look at the security of safety systems and how they interact with the control systems. And the heart of what we're doing is, along with the implementation of the cybersecurity framework in these types of systems, one of the big things that we're concerned about research-wise is the network impacts that cybersecurity has on these systems, and then how those translate to operational impacts. Especially a lot of the small and medium-sized manufacturers that I talk to are really afraid to do anything on their systems because they're not sure how it's going to affect it when they implement cybersecurity. So what we want to be able to do is provide guidance on how to implement cybersecurity in these systems while minimizing those performance impacts. Again, here's just a quick picture of some of the components in the lab. And some examples of what we're measuring within the lab. So this gives you an example on the Collaborative Robotics side for network, we're looking at path delay, round trip time, bit rates, computing resources, CPU utilization, memory utilization, and then how those translate into operational impacts. So production impacts, cycle time, part production time, throughput rate. How is this, very specifically measuring how does cybersecurity affect the production? And then also for the robot performance, does it affect the actuation latency? We noticed when we started doing some research into putting in network, latency, jitter into the system, the robots would start overshooting their positions. So again, it's just showing, and we're trying to, actually capture that, how network performance issues then translate into operational performance issues. Same thing on the process control side. Again, a lot of the network computing resources, things that we're measuring in production. Here, we found out where parts of the system that are more sensitive than others. We found out that, again, when we started, we're trying to find what areas were sensitive, started inputting in network latency, jitter types of things, and other issues. The plant would go into a warning mode pretty quick, and then if the threshold was just a little bit higher, then it would go into a shutdown mode. So again, we're just trying to show how these network performance issues can translate into operational performance issues. And then show how to implement cybersecurity so you don't get these operational performance issues. Now, always try to give something that's actionable in a lot of these talks that I give. And you kind of heard this morning. So arguably one of the biggest threats right now for manufacturers is destructive malware. And destructive malware, even though it's been in the news lately, it's been around for quite some time, going back to 2003 was so big up through all the ones that happened last year. So a couple different things that you can do to help mitigate your risk to destructive malware is to keep your systems patched and implement application whitelisting. And if you looked at SID's maturity model, those are actually the ones that are down on the left-hand side. So they're things that you want to do early on. ICS CERT has some very good documentations on application whitelisting, and I include that here. And these slides will be available to everyone. We don't keep them from going out. So configuration and patch management. So adversaries do target unpatched systems, especially the PC types of architectures that you have in HMIs, database servers, engineering workstations. When there is downtime, go through and try. You might not have to do them all at the same time, but at least have a plan for making sure all the systems are patched and up to date. In 2015, the incidents that were reported to ICS CERT, 85 of the 295, so 29% of those incidents would have been potentially mitigated by having a proper configuration and patch management program. Same with application whitelisting. So a lot of these programs, these malware programs, won't run if you have a properly configured application whitelisting process running on your systems. And it's good to use these on systems that don't change very often. They run the same programs all the time. So your HMIs, database servers, those are really good application or really good systems to deploy application whitelisting on. And again, going back to that 2015 incident report, so 38% of the incidents could have potentially been mitigated by deployment of application whitelisting. Now, one thing I want to talk about a little bit more is, so as we're going through and implementing the cybersecurity framework manufacturing profile in the test bed, there are a couple different capabilities that we want to look at in more detail. So we're working with the National Cybersecurity Center of Excellence, which is just right down the road from the NIST main campus. And we are implementing 4 cybersecurity capabilities for the manufacturing sector. One is anomaly detection, the next is application whitelisting, then malware detection and mitigation, and data integrity. We're just finishing up the anomaly detection project. There will be a draft practice guide that comes out in May of this year. So if you go to the NCCE site, that'll be available to everyone as well. And we're going to be starting the application whitelisting project in the summer of this year. And again, that will result in a practice guide that will be available to everyone as well. And with that, I'm done.